Welcome to Homework Lib.
Part A asks about the slope and the y-intercept of the regression line. These two terms tell us how the line relates workout time to floors combined. And so the slope in this context is the number 5.2150. And that tells us how much the number of floors changes for each additional minute Diane spends on the stair climber. So the slope of 5.2150 means that for every extra minute she exercises, she climbs about 5.2150 more floors. The y-intercept is negative 3.822. And that would be where the line crosses the y-axis when the workout time is 0. In this context, the y-intercept doesn't make much sense because it would literally be interpreted as Diane, if Diane isn't working out, she's climbed negative 3.822 floors. Which doesn't make sense. In the real world, in a real world context. For part B, it asks if this is a good fit for the data. And to decide if it's a good fit, look at the R squared value of 98.6%. And that tells us how well the line matches the data. An R squared of 98.9, the R squared just was 98. So technically it's 98.9%. So an R squared of that is very high, meaning that the line is almost a perfect match for the data. 98.9% of the data can be explained by the model. And so yes, this is an appropriate model because it represents the data well. And part C asks about the value of S, which is 2.3472. And this is called the standard deviation of the residuals. In simpler terms, it tells us how much the actual data points differ from the line on average. Well, I should say the actual data, I'll actually say this a little different. The actual data points differ from the line on average. An S of 2.3472 means that the actual number of floors climbed is on average about 2.3472 floors away from what the line predicts, which is a relatively small number, so the predictions made by the line are pretty close to the actual data.